Welcome back, ladies and gentlemen. In this video, we are going to continue our vector discussion, specifically some more application about dot product of vectors. The goal of this video and our objective is to be able to find the angle between two vectors. So I want to focus in first and foremost on this diagram that I have posed for you here. Now, this is going to serve as a couple of different, facets, if you will, for our diagram. One, I want to show you what I actually mean when I say an angle between two vectors. So if you see u and v, like we do right here, you have these two vectors, u, and then you have our vector v. You see that, of course, they are both in standard position, and there is an angle that is created in between them. If I wanted to find out the distance, right, from the ends, or the heads, if you will, of both of those, that is just the difference of the two vectors, so v minus u. Well, what this does is this creates, of course, a triangle for us. And now this triangle, if you remember correctly, produces a situation in which we could use the law of cosines to find the exact value of the angle. Now, because v and u don't really have any values right now, I am not going to do the full proof of this theorem utilizing the law of cosines, but it is very interesting because you have a side angle side or a side 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 scenario, hence the law of cosines can be used. So the theorem that I'm about to show you is not just out of thin air. It's created from this law of cosines. So let's take a look here at the theorem that will help us find the angle in between two vectors. And as you can see, if I'm trying to find the angle in between the two vectors, you see the dot product and the magnitude, concepts that we've talked about in previous videos. And of course, to find the actual angle, we can take the cosine inverse of this quotient that you see in our theorem. Now, a couple of things to keep in mind before we keep going here is that we do have some restrictions on theta. Theta is going to be in between 0 and pi, or if you want to consider it in between 0 and 180 if we are talking about a degree measure. So let's go ahead and take a look at an example of how we can find an angle in between two vectors. It says use an algebraic method, aka the theorem that we just talked about, to find the angle between the vectors. And then it says use a calculator to approximate the exact answer when appropriate, okay, when appropriate. So we have a vector starting at 2, 3 and another one at -2, 5. So let's go ahead and take a look at the theorem that we just identified. We have cosine theta is going to be equal to the dot of u times v over the magnitude of u multiplied by the magnitude of v. So we're going to do the dot product of uv, so 2, 3 dot -2, 5 all over the magnitude of 2, 3 u multiplied by the magnitude of -2, 5. So let's go ahead and do our dot product. So we have 2 times a -2, which is a -4. -4 plus 15, 3 times 5, is going to produce a positive 11. Now for our magnitude, so remember our magnitude is the square root of the x component squared plus the y component squared. So for this first example, I'll kind of take the long way out and go ahead and show you the full magnitude. So we have 2 squared plus 3 squared, -2 squared plus 5 squared. So we get 11 over the square root of 13 times the square root of 29. Now remember, this was all just cosine of theta. So this is not a final answer. This is not an angle. We have to go ahead and find out that theta is going to be the cosine inverse of 11 over the square root of 13 times the square root of 29. You can take the second cosine and go ahead and substitute all of 11 divided by square root of 13 times square root of 29 all in your calculator. Just make sure you use the appropriate parentheses there, and you will roughly get about 55.5 degrees, and it does fit that it is between 0 and 180 degrees. So before I continue on with part B, I challenge you to pause the video and see if you can go ahead and solve for part B on your own. So let's take a look now at part B and see if we are all on the same page once again with our angle in between two vectors. So we have cosine theta this time is going to be equaling the dot of 2, 1, negative 1, negative 3. And then that's all divided by the magnitude of 2, 1, multiplied by the magnitude of negative 1, negative 3. So I'm going to go a little bit quicker on this one, not show every single step for here. So remember our dot product, we have 2 times negative 1 plus 1 times a negative 3. So if that's the case, we end up with a negative 5. And then we have the magnitude of 2, 1. So that's 2 squared plus 1 squared. So that's the square root of 5. And then we have the square root of negative 1 squared plus the square, so we have negative 3 squared. So then we have negative 1 squared is 1, negative 3 squared is 9. So we have multiplied by the square root of 10. Now, you don't have to do what I'm necessarily about to do in all circumstances. The reason why I am doing so is because I can see that we are going to have an opportunity to simplify these fractions, if you will. Because look what happens here. You have negative 5, and that is the square root of 5 times 10 inside. So you get negative 5 over the square root of 50. And hopefully you can see why I wanted to actually do this, because negative 5 over square root of 50, remember, is the square root of 25 times 2. 25 is a perfect square. So I'm going to go ahead and have negative 5 over 5 root 2. The 5s will cancel. And I'm left with just negative 1 over the square root of 2, which really comes out to be negative square root of 2 over 2 once I rationalize that denominator. And so, of course, you could have just substituted the cosine inverse of negative 1 over square root of 2 into your calculator and got the same thing. But this put myself in a position where maybe I didn't have a calculator, and I can go ahead and clearly see that cosine, remember this is still cosine, cosine equals negative square root of 2 over 2 at 135 degrees. And again, you are more than welcome to put that in a calculator if it's provided, but may not